Okay, so now let's talk about this pocket that we're about to make in our part here. So we blew our part and we've done all of our layout lines, so we have an idea of the borders and the location of where the feature is going to take place. But we have a few different ways that we can attack this. What I want to do this time out is I want to find the center of the pocket, and then I want to use the digital readout that we have on our milling machines, and then I will be simply zeroing the readout, and I will know that I will go X distance to the right and X distance to the left, and then in Y I will go a certain distance in positive and negative, and then I will get a pocket that is 1.5 inches wide and 2 3/8 of an inch tall. So the first thing is going to be to find the actual true center position of the pocket. Well, I've made a kind of a poor sketch of what you have in front of you, your print for the part, and what we know is this. I know that from the top of the part down to the top of the pocket, we have a distance of 0.750. I know that the pocket is 2.375, the height of it I should say. Well, if I do that 2.375 divided by 2, or half of it, then I will have my a dimension of 1.1875, which is half of the 2.375. And then if I take that half, which would get us from here to here, and then I add the 0.75 to that, well, that would be the distance from the top to the center, right? So, yeah, 0.75 plus 1.1875 equals 1.9375. So 1.9375. I just said it backwards. That's what happens when you start saying lots of decimals. From here down to the center is 1.9375, 1 15/16. So I would write that down, and then I would move on to figure out how far is it from the edge of the part to the center of the part in my x-axis. So this is actually a little bit easier. I know that from the edge of the part to the edge of the pocket is 0.500. I know the pocket is 1.500 wide, so half of 1.5 inches. If I run that through a calculator, I will get 0.750. So if I took that distance from here to there as 0.750 and I added the 0.500, which is from here to here, I would get 1.25 inches. So what I just determined was an x from my xy0 that's right here, I would move over 1 inch 250, and then y, which is right here, my y0, which, you know, yeah, it's the corner, but x0 is the entire length, and y0 is the entire length here. It's just when both of them are on 0, this is where the spindle center line would be. And so from the top down and y-axis, we came up with, and this is how your readout would actually display this. It would be a negative 1.9375. It would be negative because our XY coordinate system, everything above 0 is positive, everything below is negative. So, you know, we've been working in negatives and Y this entire project, and it's just fine. Okay. So, now we would have our cutter in the center of the pocket. That's a good start. We also selected a cutter based off of the radius that are in the corners to make life easier. So if we have a radius of 0.250, that means that we should have a cutter of 0.500 because the radius of a 0.500 is obviously 0.250. Radius is half of the diameter. So now, if I have a cutter and it's hanging out in the dead center of the pocket, and it's a 1/2 inch cutter, that means that on the right side of my cutter and on the left side of my cutter, in the x-axis, I have 0.500 and 0.500. And if that doesn't make sense to you because it's out of scale, think about it this way. A 1/2 inch plus a half inch plus a half inch equals 1.5 inches. So now I've established that when I actually start to run around this pocket and mill out the pocket itself, that the furthest I'm ever going to move, positive or negative, in my x-axis is going to be 0.500. So I could jot that down somewhere. To try not to make this confusing, I get some sort of divider. So it'll be positive or negative 0.500. Now, our y-axis is not quite as simple, but it's obtainable. All we do is subtract our 0.5 cutter, the cutter diameter, from our 2 3/8, our 2.375, and that comes up to 1.875. Now you run that through your calculator, and you'll get 1.875, and then you have to divide that by 2. Now you divide it by 2 because we want our cutter to be in the center. So, you know, our total difference between these two gaps from here to here and here to here, yeah, it equals 1.875, but we divide that by 2. There we go. So our y so when we move it up and down in y-axis, or positive and negative, at the extremes, 0.9375, 15/16. Now, we don't want to go to those numbers in our first pass. We want to rough the pocket out. So just like when we're in the lathes, we're not going to just touch off on the outside diameter and dial the cut to the finished size and think that we're going to have good results. And this is going to be the same story here. So what we will actually do is, when we do our roughing passes around the inside of the pocket, is instead of going over an X all the way to 0.5, we'll go to like 0.450. And instead of going all the way up or all the way down to 0.9375, we'll just go to 0.9. Now I chose these numbers because they're very easy to remember, and they give me a pretty good cushion. So what have we done here? Let's recap all this. We had our Y0 surface, we have our X0 surface. When we edge find it, this would be our XY0 corner. We took the distance from the side of the part to the side of the pocket and added that to half of the width of the pocket to find our X, the center of our pocket in the X-axis. And then we did the same thing in our Y-axis, coming down to get the location and Y. We have it written up above. From there, we subtracted our cutter diameter that was determined based off of our corner radius. We subtracted that from first we did it from the width of the pocket, so we subtracted 0.5 from 1.5, and we came up with 1 inch. And then we divided that by 2, and we had a ½ inch and a ½ inch. That was easy. And then we did the same thing for y-axis, and we wrote it down. And then we briefly discussed that we're not going to go to those numbers on our roughing pass. We're going to go to something less than that, like I suggested, 0.450. You know, you could easily go to 0.490. Now, why did I not go to 0.490? Well, if you forget to lock a table clamp and it pulls the slack out and you're at 0.490, it's probably going to cross your line, your layout line, before you catch it. So that's bad. So I'm given a 50 thousandths allowance in x-axis and only 37 in y-axis, which is fine. Generally speaking, if you're doing it right, it's all going to work out fine. And when people make a mistake, unfortunately, they grab the handle and they turn it the wrong way. That's the most common mistake that we have. So go ahead, think about this, draw it out for yourself. It'll probably help you. I encourage you to do that, and yeah, get it done.